Serious space development for India started with the development of Indian National Committee for Space Research, set up under the guidance of Jawaharlal Nehru on the suggestions of Dr. Vikram Sarabhai in 1962, recognizing the need for space research. Later, this Space Research Committee became ISRO in 1969. In 1972, government set up Space Commission and bringing ISRO under Department of Space. ISRO built India's first satellite Aryabhata, which was launched by Soviet Space Agency in 1975. Now let's see the developments in detail. Let's now turn our attention towards launch vehicles. First generation launch vehicle of India is Satellite Launch Vehicle, also known as SLV-3. Second generation is Advanced Satellite Launch Vehicle, ASLV. These were operational during 1980s, now they are retired. This is ASLV and this is SLV-3. And then third generation launch vehicle is PSLV, which came into operation in the 1990s, famously known as the workhorse of ISRO. This is PSLV. And then we have GSLV. It is used to transfer significant payloads to geostationary orbit. This is GSLV. And then we have launch vehicle Mark III, LVM-3, previously known as GSLV Mark III, is the heaviest rocket in operational service with ISRO. A note here, these launch vehicles are variants based on the fuel used and the type of engine used, etc. Like various other factors, depending on various factors, these launch vehicles are variants. Now let's see other launch vehicles. India also have sounding rockets. These are designed for meteorological and atmospheric research, example Rohini rockets. And then we have certain launches under development like human-rated launch vehicle for Gaganyaan mission, small satellite launch vehicle for on-demand satellite launch missions, and we have a reusable launch vehicle technology demonstrator, then scramjet engine technology demonstrator. And that's about launch vehicles. Now let's shift our focus towards space missions. In 2003, China sent its first man into space, becoming the third country in history to launch a human into orbit. Following China's success, India's then Prime Minister Atal Bihari Vajpayee urged ISRO to think big. In line with that vision, Chandrayaan-1 was announced in August of 2003. Let's see Lunar Mission of ISRO in detail. We have Chandrayaan program. Chandrayaan-1 was started on October of 2008. Ended in August of 2009. Achievement is it discovered water molecules. You can say water molecules on the surface of the moon. And then we have Chandrayaan-2. It was launched on July of 2019. It included orbiter lander rover. It was a partial success because the lander Vikram got crashed on the moon surface. And then we have Chandrayaan-3. July of 2023. It included only the lander and the rover. And it was a successful mission. And then we have future lunar missions include LUPEX. It is a proposed joint mission of ISRO and JAXA, that is Japan's space agency, for exploration of the moon's south pole by 2026. Moving forward, we have Chandrayaan-4. It is a proposed mission by 2028, which includes a lunar lander and a sample returner. The objective is to explore moon surface, focusing on landing and returning samples from the moon. And that's about lunar missions of ISRO and India. Now let's see solar missions of India. At the moment we have only one solar mission, that is Aditya L1, which was launched on September of 2023. On January 2024 it entered final orbit. The objective is to study the solar corona, that is the outermost atmosphere of the sun. Aditya L1 is placed at the Lagrangian point. Here is the Lagrangian point L1. Lagrangian point is a mathematical point, a point of equilibrium. At Lagrangian point, the gravitational forces of the two large bodies and the centrifugal force balance each other. So the Earth and Sun system have 5 Lagrangian points: L1, L2, L3, L4, L5. Similarly, like other planets like Sun and Mars will have its own Lagrangian points, right? So all you have to know is Lagrangian point is a point of equilibrium. where gravitational forces and the centrifugal force balance each other. Now let's see interplanetary missions of India. We have Mars Orbiter mission, also called as Mangalyaan, started in 2013, ended in October 2022. It's a spacecraft orbiting Mars. The objective is to study Martian surface features like morphology, mineralogy, Martian atmosphere. Then we have a proposed second iteration of this mission, that is Mars Orbiter Mission 2. This includes only an orbiter proposed by 2026. Moving on, we have Chandrayaan. It is a proposed Indian Venus Orbiter mission planned to orbit Venus by 2025. The objective is to study the atmosphere of Venus. Moving on, we have Bharatiya Antarikshya Station, proposed space station by India by 2028 to 35. Now let's see astronomy missions of India. We have AstroSat 2025 to 2022. It enabled India to have multi-wavelength observation of celestial bodies and cosmic bodies using X-ray and UV spectral bands simultaneously. Moving on, we have X-ray polarimeter satellite. It is a space observatory to study polarization of cosmic X-rays. It was launched during January 2024. It will study 50 brightest known sources in the universe like black hole X-ray binaries, active galactic nuclei, and non-thermal supernova. Moving on, we have NISAR, a joint mission by NASA and ISRO. Proposed timeline is for early 2024 for a duration of 3 years. That is dual frequency synthetic aperture radar satellite to be used for remote sensing. Moving on, we have AstroSat 2, a proposed second iteration for AstroSat series. Again, it is a space telescope, second dedicated multi-wavelength telescope as a successor of AstroSat 1. Now let's see humans to space missions by India and ISRO. Gaganyaan orbital vehicle is an Indian crewed orbital spacecraft. It comes under Indian Human Space Flight Program. Gaganyaan aims to send Indian astronauts called Gagannauts to space. We have Gaganyaan 1 proposed for early 2024. It is the first uncrewed test flight for Gaganyaan program. Second iteration also includes uncrewed test flight of the Gaganyaan program. Only the third Gaganyaan program that is proposed for by 2026 includes the first crewed Gaganyaan mission. And that's about humans to space missions by ISRO. One important note here, dates are subject to change based on the budget allocation, technology, and many other factors. So before I proceed further, let's first understand some basic space terminologies. We have low Earth orbit from 160 to 2000 km, commonly used for Earth observation and communication satellites. Then we have a medium Earth orbit from 2000 to 35,786 km, mostly used for navigation satellites. And then we have geostationary orbit. These orbits are relative to a fixed point on Earth's surface, making them ideal for communication and weather monitoring. Moving forward, we have Sun synchronous orbit and Sun stationary orbit. Sun synchronous orbit is a specific type of polar orbit where a satellite passes over any given point of the Earth's surface at the same local solar time. Sun stationary orbit interchangeable with geostationary orbit, where a satellite appears stationary relative to Sun as well as the Earth. And then we have transfer orbit. A transfer orbit is a elliptical orbit used to transfer a spacecraft from one circular orbit to another. And then polar orbit that passes over or near Earth's pole. Then geosynchronous orbit. It is an orbit the same period as Earth's rotation, but it is not directly above equator. Then geostationary orbit. It's a specific type of geosynchronous orbit, but it is directly above equator. These orbits can occur together. Polar sun synchronous orbit is a great example. A combination of polar and sun synchronous orbit would refer to the orbit that is both polar, crossing over the poles, and sun synchronous. And that's about space terminologies. Now let's see satellite types. Satellites can be differentiated into communication satellites, Earth observation satellite, scientific spacecraft that is for astronomy and research, and then navigation satellites. Communication satellites mostly used for transmitting signals for TV, radio, internet, etc. Earth observation satellites used for monitoring environment, weather forecasting, and disaster management. Science spacecraft for experiments, observation, and research, and navigation satellites for providing accurate positioning and timing information for navigation and location-based services. Now that I have covered the basics of satellite, now let's see key Indian satellite series. The first Indian series we had was INSAT series, Indian National Satellite System. It primarily designed for telecommunication, broadcasting, meteorology, and search and rescue operations. INSAT 3C and INSAT 4B, great example. Then we have GSAT series. It is an advanced version of INSAT because INSAT was operational during the 1980s. To meet the art of the state technology like 5G, 6G, we needed a upgraded satellite, and that is fulfilled by GSAT series. Provides the same services for telecommunication, broadcasting, broadband services, just like INSAT but better. And then we have NAVIC, navigation with Indian constellation, used for regional navigation system designed to provide accurate positioning and timing communication. That NAVIC series we have 7 satellites. And then we have RESAT series satellites used for Earth observation and surveillance, which is capable of imaging the Earth surface even in adverse weather conditions, providing crucial data for agriculture and disaster management. Moving forward, we have Cartosat series, which has high imaging capabilities used for cartographic application and urban planning. And then we have IRS series. It is also used for Earth observation and remote sensing applications, just like RESAT series. The difference between RESAT series and IRS series satellite is RESAT series have specific usage, whereas IRS series satellites have a broader usage. Recently, India have legislated Indian Space Policy 2023. It provides comprehensive set of guidelines that outlines the roles and responsibilities of different entities in the Indian space sector. The policy is expected to pave the path for much needed clarity in space reform and encourage a private industry participation in the space economy. If you want to read more on these topics, I will put some resources in the description. You can check them out. And the next video is Important Space Missions by Global Space Agency. No commentary. I will not be narrating anything. It is a documentary style video. And that's it for this video. I hope you got something of value from this video. Like the video and share with someone who might find this useful. See you soon.